Welcome to this explainer. Today, we're looking up, way up, into the future of modern aerial warfare to decode India's highly anticipated Advanced Medium Combat Aircraft. You probably know it as the AMCA. Now, modern air combat isn't just about flying fast anymore, right? It's about processing millions of data points every single second, all while remaining practically invisible to the enemy. So let's explore exactly how the ADA and DRDO are designing this incredible machine and how they're learning from the successes and the vulnerabilities of global stealth fighters. Okay, let's dive right into this. Here is our roadmap for today. First, the F-35's hidden weaknesses. Second, defining fifth-gen aircraft. Third, India's answer with the AMCA. Fourth, smart tech and AI. And finally, features and future.
Section 1. F-35's hidden weaknesses.
To really understand the why behind the AMCA, we first have to look at the operational hurdles of the world's most famous fifth-generation fighter, $35,000. That is the estimated operating cost of the U.S. F-35 for just a single hour. It immediately establishes a massive logistical burden. Just imagine the financial strain of running a whole fleet of these jets during an extended operation. The source material we're looking at highlights that while current fifth-gen platforms are undeniably lethal, their sheer expense can actually become a strategic vulnerability in and of itself. But, that sky-high cost is really just one piece of the puzzle. The F-35 faces several documented challenges. Maintaining that incredibly delicate radar-absorbent material, the RAM coating, requires some seriously intensive upkeep. Then, you've got massive software ecosystem complexities and instances of logistics system failures that can literally ground an aircraft right when it is needed the most. Plus, when you compare it to dedicated air superiority fighters, it does face limitations in raw maneuverability and internal weapon capacity. The sources even point out a specific incident during an Iran conflict where an F-35 was reportedly damaged due to an inaccurate situational assessment. These are exactly the kinds of complex operational and sensory failures that India's defense agencies are studying meticulously so they can avoid them entirely.
Section 2. Fifth-gen aircraft.
Before we see exactly how the AMCA plans to solve those issues, let's quickly define this elite fifth-generation club. Unlike older jets, a fifth-generation fighter isn't just defined by a single metric like raw speed. Honestly, it's a flying supercomputer. It requires the seamless fusion of stealth, internal weapon bays, sensor fusion, supercruise, and highly integrated avionics. Add in network-centric warfare capabilities and low intercept probability radars, and you have a machine that processes the battlefield faster than humanly possible.
And it really all boils down to this modern aerial combat doctrine: first to see, first to shoot, first to survive. This is a massive, fundamental shift away from traditional dogfighting. Raw speed and agility, they take a backseat to information dominance. The pilot who detects the enemy first, processes that data first, and fires first, well, they win the battle before a traditional dogfight even has the chance to begin.
Section 3. India's answer. The AMCA.
And this brilliantly illustrates a core difference in design philosophy. While current fifth-gen models are often hindered by high operating costs, limited maneuverability, and these logistical bottlenecks that result in jets spending way too much time sitting in the hangar, India's ADA and DRDO are prioritizing something different. They want a cost-effective, durable design powered by AI-driven mission management. Basically, they're building a jet meant to fly frequently, sustain itself efficiently, and totally dominate the information space without breaking the bank.
Section 4. Smart tech and AI. To actually achieve that kind of high efficiency, the AMCA relies on an incredible self-monitoring flow. First, the jet continuously conducts micro-level tracking of its own thermal behavior, hydraulic pressure, and electrical signals while it's in the air. Second, all of this massive data gets fed right into an advanced flight data management system, or FDMS, which uses AI-based telemetry processing. Finally, this powers the Integrated Vehicle Health Management System, the IVHM. If we want to drop the jargon for a second, just think of the IVHM and FDMS as a digital doctor that constantly monitors the plane's heartbeat. By predicting when a part might fail before it actually breaks, the AMCA requires significantly less maintenance downtime. It spends more time dominating the skies and a lot less time in the repair shop.
But AI isn't just there to play mechanic. It's actively deployed for survival. The AMCA uses advanced artificial intelligence algorithms specifically designed to ensure flawless assessment of enemy movements. Remember that F-35 failure we talked about earlier? The one due to an inaccurate situational assessment? Well, the AMCA's AI is engineered directly to prevent those exact blind spots, making sure the pilot has a perfectly clear, digitally enhanced view of the entire battlefield.
Section 5. Features and Future. So, we've talked about the brains, but what about the muscle? The true strength of the AMCA is absolutely its versatility. Classified as a twin-engine, medium-weight, multi-role stealth fighter, it is designed to operate at massive altitudes, up to 55,000 feet. Internally, to keep that crucial stealth profile, it'll carry about 1,500 kilograms of payload. But here's the kicker. When a mission doesn't prioritize stealth, you can load it up with a much heavier external payload. It is built for everything from air superiority and deep strikes to the suppression of enemy air defenses and precision ground attacks. And this platform goes far beyond just a single jet. The AMCA is literally the foundation for India's future aerospace ecosystem. It's acting as a technology incubator. The innovations being developed right here, the stealth coatings, the advanced AI, the sensor fusion, all of that will feed directly into India's future 6th-generation programs. It's going to lay the groundwork for unmanned combat aerial vehicles and integrate seamlessly with next-generation advanced missile systems. And guys, this isn't just a distant dream sitting on a drawing board somewhere. In a massive milestone for India's defense manufacturing ecosystem, the Aeronautical Development Agency issued a request for proposal to 3 shortlisted private companies. This officially moves the MCA out of conceptual design and into an active, structural reality. Private industry and government agencies are officially joining forces right now to build this 5th-generation marvel. So I want to leave you with this final thought. We've seen exactly how the AMCA addresses the flaws of current stealth fighters by using AI as a digital doctor and a flawless battlefield assessor. With the AMCA serving as the very incubator for 6th-generation tech, is information dominance, that ability to be the first to see and the first to survive, truly the ultimate weapon of our future skies? Thank you so much for joining me for this explainer. Keep questioning, keep learning, and I'll catch you on the next one.